There's a younger me giving a definition of exclusive OR, the XOR component, along with its truth table and its circuit diagram. I think I should show you how to do the same job in the syrup language, which didn't exist when that video was made. A syrup component is like a box which has some external connectivity and some stuff inside the box that actually does the work. Correspondingly, you write the program as, first of all, a declaration that names the box and says what wires come in. That's these things. We're saying XOR has two inputs. And then there's an arrow in a declaration. And then we say what wires come out. That's just one bit. And then what we do is we write a definition. So here it's very like what I did on the whiteboard. The first thing I do is I give the two input wires distinct names. I'll call them X and Y, like in the video. And then I write an equal sign. So arrow in declaration equals in definition. I'm saying what the XOR of X and Y is. And I'm going to leave that a mystery for now and write where at the end of the line. Now, the keyword where, you're not allowed to use that as a variable name. The keyword where introduces a bunch of subordinate definitions, each of which is indented by at least one space on subsequent lines. So just like in the video, I'm going to define A to be given by X and Y. And I'm going to be defining B to be X or Y. I define C to be not A, and I define D to be B and C. And now I know that I want to give out the signal D, so I replace my question mark by my D. So I've basically copied the definition pretty much exactly from the whiteboard in the video. So this is the declaration. It gives the external connectivity, and then the main line of the definition explains what wires come into the box, X and Y, and what wires go out of the box, in this case just D. And then after the where clause, we have all the wiring that's inside the box, slightly indented. Okay, let's press send and ask the server what the score is. We get it back from the server, we see that, well, maybe I should make the editor a little bit smaller so that we can all see what's going on. We see that XOR is defined, and indeed, it's even correct. If I want to make it tell me what XOR actually does, I can add an extra line asking for an experiment. If I just ask for the result of experiment XOR, and I'll press send again, then when we get back from the server, let me just shrink the window again, we can see that the server has computed the truth table, making use of this definition. Now, as it happens, I can undo exactly the process that I performed in the video to get the truth table. When I have an equation with ordinary components on the right-hand side, I can substitute it. So I can actually take D, which is defined to be B and C, and I can substitute B and C for the D and remove the equation which defines it. And similarly, where it says C is not A, I can grab not A and replace C. Now here, it's what happened there. I have that B is X or Y, so I can grab X or Y and put it in for B. I'll have to put an extra set of brackets around that. Or is a bit like plus, and is a bit like multiply. Finally, I can grab the definition of A and substitute that out. Again, I need parentheses because not binds very tightly, and then I can get rid of the whole of the where as well as the definition of A. So now I just have a single equation that says how XOR is defined in terms of a formula. Let's see if we're still good. Let's just shrink the window again. And the system is happy.